Hello, welcome to another video, and we are considering paper 6, probability and statistics 1, that is S1. The code of the paper is 9709/63. The paper was taken in October/November 2010, and being that we are dealing with the normal distribution, the question of interest we find in question 7, which reads, the time spent by people visiting a certain dentist are independent and normally distributed with a mean of 8.2 minutes. 79% of people who visit this dentist have visits lasting less than 10 minutes. Find the standard deviation of the time spent by people visiting this dentist. Find the probability that the time spent visiting this dentist by a randomly chosen person deviates from the mean by more than 1 minute. That is 3 marks. Find the probability that of 6 randomly chosen people, more than 2 have visits lasting longer than 10 minutes. 4. Find the probability that of 35 randomly chosen people, fewer than 16 have visits lasting less than 8.2 minutes. So this is a question on the normal distribution. Of course, we are given the mean. We are to find the standard deviation. Upon finding the standard deviation, then we work out the rest of the parts of the question. So the solution to this question proceeds as follows. Well, I want us to look at problems dealing with normal distribution. Normal distribution is an example of a continuous probability distribution, and it is the last topic in probability and statistics 1 paper of the IGCSE. The topics of interest in probability and statistics 1 of the code 9709/6 are: first should be representation of data, 2 permutations and combinations, 3 probability, 4 discrete random variables, and then last is the normal distribution. I will be doing videos on all the topics, but for this particular one, we want to look at the question that we have just had projected, that of the normal distribution. So straight away, we are told that the time spent by people visiting a certain dentist are independent and normally distributed with a mean of 8.2 minutes. 79% of people visit this dentist have visits lasting less than 10 minutes. Find the standard deviation of the time spent by visiting the dentist. That is 3 marks. So first, we should remember that whenever dealing with normal distributions, it is standardized. Standardizing means we take it to Z with a mean of 0 and a standard deviation of 1. So whenever you see such an abbreviation, it simply means that the values of the Z, that is the Z scores, are already standardized. So this is a standardized Z value with a mean of 0 and a standard deviation of 1. So in our case, we are given a probability, and then the way we standardize is Z is equal to X minus mu over this, where this refers to the standard deviation, this refers to the mean of the observations, and this refers to a particular observation of interest. So in our case here, our X will be 10, because we are told 79% of people visit this dentist have visit lasting less than 10 minutes. So our X is 10, and our mu, which is mean, should be 8.2. Then we are told, realize that we have this and this, but what we want is this. The question requires us to get this. So in that case, what we'll have is, we say Z is equal to 10 minus 8.2 over this. But this is what we want. So what is that telling us? We can use the 79% for us to be able to get the corresponding reading Z value. We can get the corresponding Z value by using the probability. And so for that, we use the standard normal tables as follows. Now, the standard normal table is, that's the normal distribution function. The function is this curve, the curve here, the curve traced by this. That's the function. And the area it represents under it is these are probability. And these Z values are the standard. These are the standard, the Z scores. They have a jump of 1, 1, 1, standard deviation of 1 each. And that's why when you find the formula for standard deviation, the expression for a normal distribution, you'll find it given a mean of 0 and a standard deviation of 1, indicating it is standardized. Now, our case is we have that 79% of people who visit this dentist have visits lasting less than 10 minutes. So 79%. That has to be a probability. 79%, that has to be a probability. Then, if it's a probability, we look within the body of the table. Within the body of the table. That's where we find the probabilities. Along here, we find the Z scores. The Z scores. And here. These are the Z scores. I'll show you how we use this. This is a value of a Z score. This is it. I'll show you how that comes up. So if you want 0.79, then definitely what we see 0.79. We want 0.79 within the body of this. So if we 0.79 is this, and it's the first 0.79 that we meet. So and it's beyond the 0.79 we want because it's 0.791. So we would want to settle here where we have 0.7881. But since we want 0.79, we want to find a value which we can add along this from here. We add to this to make it close to 0.79 that we want. So we try to check, we move and see that in all this, let's try adding 16. That gives us something close. Try adding 19. Then we see that should give us, I'm working it out, you're not seeing, but I'm going to give you the answer. So 19 is 0. Yeah, that gives me 0.79 exactly. So if I add 19, to this, then I get 0.79, which is what I want, which is less than this. So how did I get that? I got that through a Z score of 0.8, and under 0. So 0.80 because this is 0 under 0. And then what did I add? I added 19, which is under 7. So it means my Z value is 0.807. And that's the value that we pick and proceed with in our calculations. Right, we see that the probability, the corresponding Z value is 0.807, which we now equate to 8.2 over this. This should give us standard deviation. If we make this the subject, that is supposed to give us standard deviation of 2.23. Standard deviation of 2.23. That's what we should have. Then, that being Roman 1. So one thing we need to note is how to read the value of Z using the corresponding value of probability. Once we have that, then equate and get that. Then Roman 2, find the probability that the time spent visiting this dentist by a randomly chosen person deviates from the mean by more than 1 minute. So that's probability that it deviates from the mean by more than 1 minute. So I will take the modulus of that. So that means I'm restricting the value of z. And once I have that, so it's greater than, we say 1 minute, actually 1 minute from mean. 1 minute from mean is greater than 1. Okay, find the probability that the time spent visiting this dentist by a randomly chosen person deviates from the mean by more than 1 minute. Yeah. So this can be the probability that we have 2.23 as such. So it's probability that the modulus of z is greater than the reciprocal of this. Now, this implies that probability that this modulus is greater than, now the reciprocal of that should be about, the reciprocal, if you check using your calculators, should be about 0.4484. That's the reciprocal of this. And so what we are given here is the probability where the absolute value here is greater than this. So for us to find the corresponding z value, we need to read this value from the table again, so that we see what probabilities it corresponds to. Because here we see that the z value, we are saying that the positive value of z is greater than 0.4484. That is z. Now we want to define the probability that is associated with this. Now that probability will be given by 1. It is 1 minus 6729, which is what we get here. That is what we get once we read this. I'll be showing you how to get this straight away. Just a minute. This is now, for this part, we have that probability that the modulus of z, the z score, is greater than 0.4484. So the z score is greater than 0.4484. So our interest is in finding the corresponding probability, the probability that corresponds with the z score. So in which case, we see that z scores, we find them here. So if I come here, I find 0.4 here. Then I would want to move up to the point where I have 0.44. There I get 0.6700. I note it somewhere. Then it is 0.4484. So I move to 8 because 4 is small. I would have taken 9, but now I move to 8. So I get to under 8, I find 29. Under 8, I find 29. Then I add 29. That gives me 0.6729. 0.6729 is our value of interest, and that is the corresponding probability that the probability that corresponds to a z value which is greater than 0.4484. So we take it and proceed with our solution as follows. Yes, we see that this gives us this As you have seen, therefore it allows us to write, because all that has already given us the value, so that allows us to write 1 minus 0.6729 times 2. So you need to know what we have implied here, what 1 minus phi of a particular angle should represent. Then we get here. Now, this leaves us with the probability. If you subtract this from this, then multiply by that, then the answer that you are supposed to get, I'd work them out. And so you need to confirm. You need to confirm if the answers I'm giving are consistent. So from my end, I'm already convinced. So you need to do it yourself so that you are convinced that the values that we are giving here are indeed the true values. So that should give me 0.654 as the probability that I want. Then, after that, the third Roman 3, is asking me, find the probability that of 6 randomly chosen people, more than 2 have visits lasting longer than 10 minutes. So that will be the probability that more than 2 people, yes, more than 2 people, that would be given by 1 minus probability that it's 1, no, it's 0, 1, or 2. So if I get this probability and subtract from 1, then that should specify the probability, because the total probability should add up to 1. And in the event that we get for 0, 1, 2, 3 and subtract from 1, that allows us to specify probability of having 3, 4, 5, and 6. So here we are going to use this formula here to get this. It will be summation. Sorry for that. It will be summation. Oh, I didn't even. Yeah, it will be summation x from 0 to 6 of C6 combination x, p raised to power x, q raised to power n minus x, like that. That will be the expression of the probability. Let me just try to get another pen. This will be okay. Sorry for that. So that we are clear. I want us to be clear. But so as I was saying, once we have this, now I've sorted out the issue of the marker pen. Now I hope it will behave. So we start with when it's 0. When it's 0, we are going to have a situation where we have 6, combination 0. Then P is 0.21 raised to power 0. Then Q is 0.79, which is now raised to power 6, plus 6 combination 1 in times 0.21 raised to power 1, 0.79 raised to power 5, because it's n minus x, then plus 6 combination 2, that's now when there are 2, times 0.21 raised to power 2 times 0.79 raised to power 4, because it's 6 minus 2 raised to power 4. So this one will represent the probability that there is 0, this there is 1, and this there is 2. So by adding these probabilities and subtracting from this, you should be able to get this probability. Now, if you work out this and get their value, you should be able to find that the corresponding probability of interest is 0.112. 0.112. That's the probability. 0.112 is the probability, and so it is the answer to part 3 of the question. I need to move to part 4 of the question. Part 4 of the question, which is asking me to find the probability that of 35 randomly chosen people, fewer than 16 have visits lasting less than 8.2 minutes. Now, because I'm not going to need this result again, I want to rub it from here. I may need to make reference. I don't have to. So let me just rub this. This. Yeah. So with that, we first say that, okay, we know that we need to write our expression in the form z is equal to x minus mu over this. And we know that mu, the defined mu now, because that 35, should be 35 times 0.5, which is 17.5, because of the concept of the aspect of randomly chosen. That means equally likely, equal chance. And so if that's the case, then our corresponding variance can be given by 35 times 0.5 squared. 35 times 0.5 squared. Because it's NP, it's actually, we are using NP. But for the variance case, this case is NP, meaning n times that probability of success, but variance will be NPQ. Yeah, so our P is 0.5, our Q is still 0.5. That's why we have 0.5 squared. Now, that gives us this value to be that, and this second one, we get it to be 0.5 squared times 35 should give us 8.75, implying that root, which is the standard deviation, is root of 8.75. Now, for us to get, then we are asked probability that x is less than 16. We then need to define the lower boundary of 16 because it's not touching 16. And that we can pretty well say is 15.5 minus 17.5, which is the mean, mu, and divided by the root of 8.75, divided by root of 8.75. If you do that successfully, then you should realize that the answer that you are getting leads you to something close to this, leads you to 0.6757. This gives you that. But look what we have. We are just saying that probability, we are saying that probability that x is less than 16 gives us a z-score of this. This is the z-score. This is the z-score. So actually, I'm not even supposed to equate. I should just say this. I should just say this. Yeah, so that I'm not equating. But with reference, I'm using this concept to get that. So if this z refers to, if this z refers to where a situation where we have this, then what is the corresponding probability? So in other words, that's the z value. We need to read the corresponding probability. And so that we do by a minute, what is here? This is a negative because 15 minus 5.7.5 divided, that's a negative. So we have this. We have negative 0.6757. It's a negative. So when you have a phi of negative 0.6757, that should then mean that we are dealing with 1 minus phi of 0.6757. And this is 1 minus, we check the corresponding probability using this z. So in other words, we look up the value, the probability that corresponds to this z value from our table as follows. Here we want the probability that corresponds to a z value of 0.6757. 0.6, so the z value is 0.6, then 757, then 7, 7, 7, 7, 7. We find 7 here. That gives me 0.7486. So it's 0. That was at 0.67. But then I also need 6. So 0.67, then I go under 6, I find 19. So adding 19, that gives me 5.0570. That gives me 0.7505. 0.7505 as the corresponding probability, and is the probability now that we pick and insert in our solutions to get the answer as follows. Well, now we know that this corresponds to a value of 0.7505. And so the probability of concern that we have been looking for is 0.2495. 0.2495. So that's the probability. That answers the entire question as we had intended. And I hope you followed all the tricky bits that you needed to, so that once you get such a question, next you are able to attempt, if not solve. So that's that. I urge you to like, subscribe, and comment. See you in my next video. I'll still be coming back with the probability.